In this lecture, we'll pick up with the idea of the different data types that we need to consider when we are defining our variables for our program. So we're going to start out with the integer data type. Integer data type is indicated by the keyword int. So you can see these variables have this definition of an int. Now, if you recall from your math, integers can only be whole numbers. All right, so the idea of declaring variables of a data type allow us to manage how much space in memory is put aside for each of those variables. So for an integer here, the integer in itself goes from anywhere from minus 35,000 to positive 35,000 in size in terms of the number I can choose. Anything beyond that number or below that number, we would have to use a different data type. Now, each of the languages are a little different. Java, I can use many more place values than I can in C++. So I'm limited to these lengths right here, this size right here. So if I wanted to store 1,000,000, then I would have to either use the unsigned int or I would need to use a long, what we refer to as a long. Syntax matters. Remember in our last lecture, it is a case-sensitive language, and so your capitalization or lack thereof does matter in creating our variables, but also using our keywords. So an integer, they've declared length and width to be of integer type. They can only hold whole numbers. We'll see in the lab what would happen if I tried to store a double in my integer, okay, a decimal value into my integer. So we can declare them as separate lines. So these are 3 separate lines of execution here at the top, or I can combine them together, okay, in the same one using the comma to delineate between one variable and another variable. Variables of different data types, however, must be defined on different lines. So here, because this one is an unsigned int, it is on a different line from the 2 that are regular ints. So here we can see a program, again, the idea that I must declare them first. So here's a long. The long is going to be allowing for numbers that are even larger. Okay, so the int is going to be checking. An unsigned int is miles. And so long is days is going to be of long type. So when they define them and give them value here, checking, a regular int can be plus or minus. The miles here is a 4-digit number, and then the days here you can see is much larger than 35,000. And so therefore they needed to use a long instead of a regular int. And then once they've declared them, they must give them value also before they use them. This is called direct assignment. Shortly, we'll learn the idea of using input, and that will also give value. Okay, but I needed to give them a value before I could use them in these statements for output. Otherwise, I will get an error, and C++ doesn't do this checking of value. It's just going to give you garbage, and we'll see that in the lab. We have the char data type. So what a char is a single character. It has 1 byte of memory, okay, and all it does is hold the ASCII value of the character. We talked about characters in basic, and so it is used to hold, as you can see, a single character. I had shared with you the single quote, also an apostrophe. When we refer to it in programming, it's a single quote, but we use single quotes to signify a character, a char data type, over a string data type. Okay, so this can only have 1 character inside of the single quotes. Otherwise, I'll get an error. All right. In memory, it is storing a 67. It's interesting. It actually is holding its mathematical value, okay, versus the character itself. And we'll actually be able to add with it, and we'll see that as well. Okay. And so again, the idea of the single quotes. And that's why we also needed the escape sequence so that we could override the meaning of the single quote, which is used for a char. Here we see the char, they declared a char, they assigned a char, and then they outputted the char. In this case, it is giving us the letters A and B that were there, not the number 65 and 66 that are actually stored in memory at its declaration. We have the string. Now, the strings are a little different here versus our other data type. We actually need to use one of the preprocessor directives in order to use a string because the string itself is an object and has a class associated with it. The primitive data types, which is what a char and an integer are, don't have that, but string is not considered a primitive data type, so we must use the directive, the pound include, in order to execute strings. Here, though, we declare them in the same way we did previous values. Here, we declared string to be first name and then last name. Here, they're using camelback lettering when I use two words that I mushed together to create a variable name. That is very common in terms of best practice. Here then they declare first name to be George, last name to be Washington. Here they output first name George and then added a space. We needed to add the white space so George Washington was one, looked like one name with a space in between. So here we have the declaration of the movie title, and then they're going to output movie title to the screen. So a floating point data type. So we talked about the int, which are only whole numbers. Floating point allows for decimal value. Now, if you recall from your math, though, integers can fall under decimal values because we can write an integer as a decimal value with the idea of that 0.0 at the end. So I can include my integers in my decimals. I just can't include my decimals in my integers. So we have three different types. Now they do have different size. The float is the smallest of the three, and then we have the double, and then we have the long double. The book and some of the code I give you uses a float. In Java for the AP class, the testable value is the double, and so I more times than not will use double for that reason, just to get you used to that. But this can hold numbers that are, as you can see, regular decimals, whether they're positive or negative. They are stored in the form of scientific notation, and we'll see that when we look at displaying some of these values. All floating point numbers are signed, so they do have plus and minus, the ability to have the plus minus. And they're pretty large. I mean, it takes a lot to cap out, to overflow a float, no less to overflow a double, in terms of the overall size. Again, this hasn't changed, but the idea here, they did use scientific notation. Here, you don't have to use scientific notation, but they did here. But you can see that it displayed it in the form of scientific notation, and we'll talk about that a little bit later on as to how to correct that in our output. Bool, we didn't have the bool before. The bool is the idea of a Boolean. Okay, Boolean is the name. Boolean is a keyword for other languages like Java. We use the Boolean data type, not a bool. But the bool allows for the idea of true or false. So it has one of two states. It only takes up the size of a bit. Okay, it holds the idea of true or false. And so they do have value though as well. So true and false are not necessarily keywords in C++ like they are, let's say, in Java. Okay, they do have value. The false has the value of a 0, so it has numerical value. A true has the value of a 1. So here we can see they declared bool all done equals true. Now you can assign it. So this will assign all done to equal 1. This will assign all 1 to equal 0. Okay, and that's what gets stored in memory. And so I can assign it a true or a false, but on display, it will not give me a true or false. Now it's cut off the bottom of the screen so for the viewing of this video, but this will print let's see, bool value is equal to true. So this will print a 1 to the screen. It does not print the true or false that I assign it. This will print a 0. C++ doesn't allow for that. Java would allow for that. C++ does not allow for that. You would have to test to see if it was a true or a false and then override it by displaying true or false as a string. Okay, but it does have the value of a 1 or a value of a 0. Variable assignment and initialization. So the idea of an assignment statement uses the equal sign. We know that from our previous experience. The equal sign is not used for equality. It is showed to assign what is to the right to the left. So the assignment happens from right to left. Okay, and that will happen when we look at our math expressions. So this statement assigns the value 12 into the memory location of item. So to initialize, I can declare it first, or I can initialize it, but I can't do both. Okay, so it does, I can do this and then do this, but I can't do both of these. Okay, so it's one or the other. So I can do these two, which were my previous examples to you, okay, or I can do this as an all-in-one. Sometimes you have to do that, and we'll see that as time goes on in the lab, but I don't always have to do that. I can initialize more than one item at the same time as long as they are all of the same data type. All right, so this will assign 12 to length and 5 to width, and area just doesn't get a value, okay, and that is legal. Okay, but again, I can do it as two separates, or I can do it as an all-in-one. So here we can see they have assigned month to 2, days to 28, and so this will print out month 2 as 28 days. So the last thing we're going to talk about is the idea of scope. And so scope is how visible is a variable in your program. Okay, the part of the program in which the variable can be accessed. A variable cannot be used before it is defined. And so we can think about the idea of local scope. So this is within the statement block. Okay, or function, all right, and we'll see this more when we get to functions. And then we also have global scope. And so global scope means that all statement blocks and functions have access to it. And functions have access to it. Okay, and when we look at this in a program and we look at function blocks, we'll be able to see more how that looks in our program. So here, this one is said to have a local scope only to the main function. Okay, nothing outside of the function, nothing out here or here can actually see the variable value. So we talked today about data types. We talked about declaration.